Lesson 5, Solving One-Step Equations. So in this picture here, you see a balance. When we solve equations, we want to view them like a balance, where the middle of the balance is where our equal sign is. And we want the two sides to be equal to each other at all times. So if you notice, on the right-hand side, we have 5 plus 4, which is equal to 9. We need to think to ourselves, what do we need to add to the left-hand side for it to also equal 9? And in that case, it would be 7. Now, it's not going to be as simple as this, but keep that idea in mind where you want your equation to always be balanced. So here is kind of just a summary of what I just discussed. The basic idea is that we have an equation that is balanced on both sides. Whatever you do to one side, you must do to the other. So, if I added a 5-pound weight to this side, now the right side of our balance would weigh more than the left. So if I add 5 pounds to the right, I have to also add 5 pounds to the left. Our goal when we're solving equations is to get the variable alone. And remember, a variable is just a letter. Most often you'll see us use the letter X, but it can be any letter that is in place of a number. So let's look at an example. To solve for X in the following equation, our equation is X plus 21 equals 31. So first we're going to draw a line down through our equal sign so that it's like our balance. This is our left-hand side of our balance, and this is our right-hand side of the balance. Step 1, identify what is happening to the X. So I'm going to look here to see what operation is happening to the X, and I see that 21 is being added to it. So in order to get that X by itself, we need to get rid of the plus 21. In order to get rid of plus 21, it's kind of like we want to cancel it out to 0. So we are going to do the opposite, or the inverse operation, and the opposite of addition is subtraction. So when I actually do 21 minus 21, these guys cancel out to 0. But if I only subtract 21 from the left-hand side, then my equation isn't balanced anymore. So you'll notice that I subtract 21 on the left, I also subtract 21 on the right. And when I do that on the left-hand side, I'm left with X, and on the right-hand side, I'm left with 10 because 31 minus 21 is 10. Now we have to check our solution. So I'm just going to erase what I have here. Step 1 is to rewrite the original equation. So you'll notice these two equations are exactly the same. Now instead of solving this, we want to check to see if X really does equal 10. So what we do is we take 10, we plugged it in where we saw an X, just like we did when we were evaluating expressions. We took that number and we plugged it in for the variable, and then we kind of ask ourselves, is 10 plus 21 equal to 31? Yes, 31 is equal to 31, so it checks. Your goal when you're checking is to make sure that the left-hand side and the right-hand side are equal to each other. So let's try a couple together. So example 2 says solve and check the following equations. Ask yourself what is being done, or what operation is being done to the variable. So if I look here in letter A, I need to identify what is happening to the X. So I see that subtraction is happening, and in order to undo subtraction, I need to use the opposite, which is addition. So I undo subtraction with addition. So I'm going to draw my line down through my equal sign. And again, the goal is to get the y by itself, so I need to get rid of minus 6. So I'm going to do the opposite, which is plus 6. But whatever you do to one side, you have to do to the other side. Negative 6 or minus 6 plus 6, they cancel each other out. I'm left with y on the left-hand side, and 18 plus 6, which is equal to 24. Now I have to do a check. So for the check, I rewrite the original equation. I'm going to substitute 24 in for y. So is this true? Well, 24 minus 6 is 18. So the two sides equal each other, which means it checks. Let's try the next example, letter B. Now this one looks a little bit different than the past two because the variable doesn't come first in the equation, but everything that we do is still the same. We need to first ask ourselves what operation is being done to the variable. I see addition, so we're going to undo addition with the opposite, which is subtraction. So my goal is to get x by itself. So I'm going to minus 9 from both sides since that's what I want to get rid of so that the x is by itself. 9 minus 9 is 0, so these cancel out. And you're left with x is equal to 25 minus 9, which is 16. Now we have to do our check. So I'm going to rewrite the original. I'm going to substitute our answer in for x, because we're checking to see if this answer is correct. 9 plus 16 is in fact 25, so our solution checks. Now if you notice so far we've only dealt with addition and subtraction. So now we're going to move on to multiplication and division. Important, when solving equations algebraically, we do not use x for multiplication or the division sign for division. We definitely do not use x anymore because now you see x is being used as a variable. So instead, we're going to use either a dot or parentheses. Parentheses, I think, are neater, are a better and easier way to show multiplication. And we always write it horizontally, not like with addition and subtraction where you see us writing it underneath, like here and here. It's going to be actually written next to the problem. Same with division. We're going to use a fraction bar to show division, not the division sign. And it'll make sense when we do these next two examples. So, step one, still the same, asking yourself what is happening to the variable. So, I draw my line. I see here a number next to a variable. Now it's kind of hard to understand what operation is happening here because you don't see a plus sign, you don't see a minus sign, you don't see multiplication sign, and you don't see division sign. So I just want to, nothing to do with these two examples here, but if I had, let's say 4x, and I told you x was equal to 5. And I wanted you to evaluate it, which means plug 5 in for x. We always use parentheses when we evaluate. Now you can see that we have multiplication happening. So when you have a number in front of a variable with no operation, it's multiplication. So here, we need to undo multiplication with division, because they're opposites of each other. So to get rid of 3 times x, we're going to divide by x. And using the fraction bar, I'm going to draw a little line underneath each side of the equation, and I'm going to put a 3 underneath it. So what this is showing is 3 divided by 3. And any number divided by itself always cancels out to 1. So I'm left with 1x is equal to 12 divided by 3, which is 4. Now you're probably saying to yourself, well, the variable is not by itself. Well, when there's a 1 in front of a variable, that 1 doesn't change the value, because when you multiply something by 1, it stays the same. So I don't even need to write that 1 in front of the variable. When two constants or two numbers cancel out with division, they just cancel out and there's nothing there. So my answer is x equals 4. But now we need to do our check. So I'm going to rewrite the original. I'm going to substitute 4 in for x. 3 times 4 is 12, so our solution checks. Example 3, letter B. I have n over 6. And if you remember from past lessons, when you have a fraction, that operation is division. So here we need to undo division with multiplication. So I'm going to go back up here where it says to use a dot or parentheses to show multiplication. So two things you can do here. You can do the dot 6.6 because you always want to get rid of the number that's with the variable, or you could also put the parentheses. You'll see me use the parentheses more often than the dot, but either is fine. What we don't want to see is this. Yes, it's mathematically correct, but it's messy, and you won't ever see any of your teachers do it that way. So I'm going to show multiplication on both sides, multiplying by the number that's with the variable so that they cancel out. And you're left with n equals 4 times 6, which is 24. And just to explain to you why multiplication cancels out division, if I rewrote what I have here on the left, this is what I have, 6n over 6. When you multiply a number, it's really over 1, and we always multiply horizontally. So 6 times n is 6n. 1 times 6 is 6, and then these 6's cancel each other out, just in case you were wondering why it is that multiplication undoes division. Now we need to do our check, write the original, substitute in for the variable, and we do in fact get 4 is equal to 4, so it checks. Those are the 4 basic kinds of one-step equations that you're going to see. So just to go back, we had subtraction, so we undid subtraction with addition. Here we have addition, we undid addition with subtraction. Here we had multiplication, which we undid with division. And here we have division, which we undid with multiplication. So like it says here at the top, opposites undo each other. So you need to make sure you know what your opposites are. And just for fun, we're going to try a challenge together. This one's challenging because it's hard to identify what operation is being done to the variable. So I want us to think back to the example I showed you where it was 4x and we substituted the 5 in for the x, and when you have a number next to a variable, it's always multiplication. 3/4 is just like any other number. I could put a 2 here and it would be the same thing. 2 next to x represents multiplication. 3/4 next to x represents multiplication, because I could rewrite this as 0.75x equals 12, because 0.75 and 3/4 are the same thing. What confuses people is that they see a fraction, so they think that division is happening. There's really no division happening between the number and the variable. So just like in all of our other examples, to undo multiplication, I'm going to use division. So I'm going to divide both sides by 3/4. When you divide a fraction by another fraction, or a whole number by a fraction, it's called a complex fraction, which is fine. It just looks messy. So these cancel out, and you're left with x equals 12 divided by 3/4, which you can do in your calculator, but if you don't have your calculator, if you write this horizontally, you have 12 divided by 3/4, and if you remember back from elementary school, to solve this by hand, you do keep, change, flip. So 12 times 4 is 48. 48 divided by 3 is 16. So x is equal to 16. Now, if you want to take it one step further and solve this in a cleaner way, there is another way you could solve this. So I'm just going to erase this division by hand, and I'm going to rewrite the problem here. I have 3/4 x equals 12. Another way to cancel out fractions is to use something called the reciprocal. The reciprocal is just the fraction flipped. So if I had 1/2 times 2/1, those would actually cancel each other out. Same thing with 4/5 and 5/4. They would cancel each other out. So if I wanted to cancel out 3/4, I could actually multiply both sides of the equation by the reciprocal, which is 4/3. That only works when you're trying to get rid of fractions. You still will wind up with the same answer, because 12 times 4 is 48, divided by 3 is still 16. Whichever way you want to think about it, it's totally up to you. Some people like to stick with the fact that we have multiplication, which we undo with division. Some people don't like dividing a fraction by a fraction, so they use reciprocals. It's totally fine. Again, this is a challenge, so if you understand this, that's totally great. I do have to check this, though. So I have 3/4 x equals 12. I'm going to plug 16 in for x. 3 times 16 is 48. 48 divided by 4 is 12, so it checks. So go ahead and head back to the Zoom and give the problem set a shot.